In this video here, we're going to take a look at special types of graphs. Now, there are a number of special types of graphs that you do need to be familiar with, namely trees, spanning trees, complete graphs, and then finally here, isomorphic graphs. So I think the best thing to do here is just take a look at each type of graph in more detail. So let's get started then with trees. So the first special type of graph that we have here are trees. Now, a tree is a connected graph with no cycles. So the graph below, that's this graph here, is a tree because we have no cycles, right? We can go from each point here to the next point without forming a cycle. However, this graph, that's this graph here, is not a tree as it contains a cycle. So that would be D, E, F, D. So D to E to F to D again. It forms a cycle, right? So hopefully that is quite intuitive that if it forms a cycle, it cannot be a tree. Okay? So moving on to the next type here where we have spanning trees. So a spanning tree of a graph, let's just say G here, is a subgraph which includes all the vertices of G and is also a tree. And if we just start with this graph here, for example, then some possible spanning trees could include the following. So this here is an example of a spanning tree, as well as this graph here. And for some graphs, there could be many different spanning trees. So for the next type of graph here, we have complete graphs. Now, a complete graph is a graph in which every vertex is directly connected by a single edge to each of the other vertices. And we write the complete graph with n vertices as kn. So the subscript there, n, denotes the number of vertices for a complete graph. And some examples are demonstrated below. So to get us started here, we have K3. So K3 here is a complete graph with 3 vertices. So we denote that as K3. For the next example here, we've got K4. So what I've got here is a complete graph. We've got 4 vertices, right? 1, 2, 3, 4. So we denote that as K4. And then finally, for the very last example here, we have K5. So what I've got here is a complete graph with 5 vertices, right? 1, 2, 3, 4, and 5. So we denote that here as K5. And now for the very last type here, we have isomorphic graphs. Now, isomorphic graphs are graphs which show the same information but may be drawn differently. So what I've got here is 2 different graphs, but these 2 graphs here are actually isomorphic. So these are isomorphic graphs. So for isomorphic graphs, it is possible to pair equivalent vertices. So in this case here, A can be paired with P. Notice that in this case here, they both have order 2. B can be paired with Q, so B here again has order 2, and the same is true for Q. So C here can be paired with R, so again C here has order 2, and the same is true for R. D can be paired with S here, so D then has order 3, and the same is true for S. E can be paired with T, so E here has order 2, and again the same is true for T. And then finally, F can be paired with U. So F here just has order 1. And again, for the very last time here, U also has order 1. So in terms of an introduction here to special types of graphs, that's everything that we actually need here. So as always, I think the best way to really demonstrate and work through these skills then is just work through a practice question together. So let's just get started then with this practice question here. Now, for this practice question then, as we can see here, it's pretty brief and pretty light in terms of detail. There's just the 3 parts here, right? So for part A then, all we want to do here is draw K3. For part B, we want to state the degree of each vertex in the graph Kn. And then finally for part C here, we want to find the total number of edges in the graph K15. So hopefully it should be pretty straightforward. But yeah, let's just get started with part A then. So for part A then, as we just said then, all we want to do here is just draw K3. Now, we did actually introduce K3 as part of our introduction here for special types of graphs, right, when we were discussing complete graphs. So K3 then is the complete graph here with 3 vertices. And the way that we draw this here is a triangle, okay? So if I just draw my triangle here, it doesn't have to be perfect, by the way. Just something like this. Clearly, these should be straight lines. As you can see, my art skills are certainly not the best, but it doesn't really matter too much, right? This here is K3, and that's absolutely fine. Okay, so there we go then. That gives us the solution to part A. Now for part B, then what do we want to do here? So it says state the degree of each vertex in the graph Kn. Now, in the graph Kn then, well, what I'm going to have here is n vertices, right? Now, each vertex is connected to all the other vertices. So in that case then, each vertex must just simply have order n minus 1, right? Because it's connected to all the other vertices. So each vertex has order n minus 1. I'll just make a note underneath here that they're connected. So connected here. So connected to all other vertices. Okay, and that's absolutely fine there. And then finally for part C here, what do we want to do then? It just says find the total number of edges in the graph K15. So obviously we can now use this answer to part B here to help us with part C. So each vertex then is going to be connected to 14 others, right? Because it's got order n minus 1. So each vertex is connected to 14 others. So in that case then, the total number of edges, so total number of edges is equal to, so it's going to be 15, because that's my subscript here, times by n minus 1, because that's how many vertices it's connected to. So 15 times 14. But just be slightly careful here. What we need to do now is divide by 2. So we divide by 2, like so. And just in case you're wondering, then the reason that we divide by 2 here is to avoid double counting. So I've got 15 times 14 divided by 2. What does this give us here then? So put this into your calculator. What you'll get here is 105 there. Okay. And there we have it then. So like we said at the beginning, quite a straightforward question, and hopefully you have found that to be the case. And there we have it then. So that gives us the solution here to the one practice question for this video. And that brings us to the end then of this video here on special types of graphs.